Hello! Today we are going to talk about LaserDisc. Why am I going to talk about an obsolete recording format? Well, because all of the optical recording we do these days traces the technology back to LaserDisc. So as I explain LaserDisc, I will be explaining the basic technology of how CDs, DVDs, and Blu-ray work. And so let's get started. And before we had LaserDisc, there were other attempts at optical recording. I think Alexander Bell did something. I might be a little wrong about this, but the idea he had was to have a piece of smoked glass, so glass with carbon on it, and he would have a needle hooked up to a diaphragm and move the glass past the needle or vice versa and get these wavy lines, voice-shaped lines, if you will. I don't know if they had any way or attempted to play it back or anything, but he did have this recording of pretty much what we see on an oscilloscope these days of the wavy lines that the voice makes over time as we change the amplitude. But later on, there were other attempts using film to record by changing the density of the film to represent the amplitude of the signal. So if I go in modern terms, I have a microphone, there's a diaphragm in there, and if I speak, the diaphragm moves away from me, the whatever's making the recording on the film would become brighter, therefore making the film darker. And as that diaphragm came towards me, it would do just the opposite. It would make the light dimmer, therefore making it lighter. And we get a darkness-based recording, and that could be played back in the early days, would be done with a photosensitive tube or something like that. Now, one of the most common methods of doing optical recording was on film. And so if we look at a typical, back in the day, probably before most of you, we had 16mm film in our schools and no videos, just film. And so there's a bunch of pictures, and this goes by the pictures one by one. I don't know how many frames per second. The frame rate was pretty slow to save film. And over here was the soundtrack. So actually, if I want to make this a little bit wider, so we had the sprocket holes over here and the soundtrack over here. If we look at the soundtrack closely, we would see something like, well, let's look at Bell's voice-shaped currents, except it would be kind of like a mirror image if I can do this. Doing okay, yeah, I'm not doing too bad, could be doing worse. There we go. So I'm not exactly sure how they recorded this. How did they get this to be wider and thinner? So wider, more light goes through. So it's like when I talk on the microphone, the diaphragm goes away from me, it gets wider. And when the diaphragm's coming closer to me, it gets narrower. How they did that, I have not been able to find out. But the soundtracks I saw always looked like that. They could have been density based, like I mentioned before, where it would get more dense and less dense, but all the soundtracks I ever saw looked like this. And of course that would go to a photosensitive tube and be amplified inside the projector, and we had talking movies. So that was very, very common until the 70s, when videotape started to take over from film to show what we call video today in those kinds of venues. We'd say show a film, now we show a video. So that was an analog method of optical recording. But in the 1960s, a man named James Russell developed a way of making digital optical recordings. What I can find out about it is rather vague, but his was basically photographic film, and he would use a laser, must have been pretty expensive in those days, to put spots on there. Were they closer together, further apart? I don't know exactly how they were formatted, but he is able to record digital information on those spots. They did not use a laser to read it, but they would shine light through it, and exactly how they read it, I've not been able to find out, but it was a matter of recording digitally on film. But when the LaserDisc was developed, this was close enough to what LaserDisc was that he successfully defended patents on his technology, and so those making LaserDiscs and later CDs had to pay royalties to his company to be able to do their technology. But let's take a look at how that technology works. And the reason it's called LaserDisc, well, first of all, why did we use lasers? I talked about laser earlier, and one of the problems of white light was what? That white light has all sorts of colors. So if I have a lens here, and a white light, let's say it's collimated white light coming in from a light bulb some distance away, and I focus that light, what's going to happen? The red colors are going to focus at a different place than the blue colors. And so I have a range of focus. And so I can only get that focus so small before it starts to get bigger again. So I focus down, and there's a range where I go through the colors. Of course, it'll look white because it's all blended together, but I can only get so small, and then it'll get bigger again. But what if I have a single color coming through, such as with a laser? So now we have a laser, draw a crude laser tube here. We're going to use a negative lens to let's see, go through the negative lens to spread it out, and go through another lens to collimate it. Gets a little complicated, doesn't it? There's our collimated laser light, but that is a very pure color, so when we focus it, it's not going to focus into a range, but to a spot. And the spot we can make that laser focus to is directly related to the wavelength. So a shorter wavelength can be focused down to a smaller spot than a longer wavelength. And I don't know what we used for the earliest recordings, but eventually when LaserDisc was developed for the home market, we used helium neon lasers, which I explained in my previous video, which produced a red light. And that red light, being fairly long wavelengths, could focus down to a particular point. I don't know how small it could be. Maybe I'll look it up and stick the number up there. But we could focus it down to a very tiny point, much tinier than white light. And once we can do that, we can manipulate this to make some optical recording. So the LaserDisc was a mechanical format. So the process ended up with a plastic disc. There's one side of it, and the other side would have molded into it what they called lands and pits. So I'm just showing them all the same length here. And they would coat this with aluminum to be reflective, and they would sandwich that between a couple of layers. They were pretty thick. In fact, they were two-sided, so we had multiple layers of this. So I'll just draw the other one here. There's another one, completely unrelated material for the other side. And sandwiched together with the aluminum coating and all that we have there. And so it could be read from either this side or this side. And so the laser beam is focused on these pits. And how small can we make them? Depends on the wavelength of the laser. So compared to what we can do today, these lands and pits were fairly big. So let's take a look at it from the top. And if we look at some of these, here's a picture of one actually. But these would be various lengths of pits, and they would be in parallel tracks. Actually, we have a single spiral track of these pits. The LaserDisc started reading from the inside and worked its way to the outside. And if we focus the laser on these, now, one thing I'm not sure about is exactly how these were read, and I can't find good information on it. And some say one way, some imply another way. But we could either see something happen at each transition, or we could see, well, a land is seen as one thing because it reflects one way, and the pit reflects a different way, so it's seen as a different entity. So basically, there's your land, there's your pit, there's your land, there's your pit. So it would produce a square wave. Or it could be at the edges where we get something more like a spike there where it goes in and a spike there where it comes out. And we might be able to encode twice as much information in there if they use that method. So I think I would have tried to use this to squeeze more information in, but I don't know. But anyway, the information is put in there by different lengths of pits and different distances between them. So that's basically how the information is put in there. The laser is focused on there, and what they do is they split the laser into 3 beams, and they skew them across there, and they can keep moving the lens system to keep the reading spot in the middle by seeing what comes back from these and keep adjusting to keep that in the middle. So they split it into 3 and read from the middle and adjust from the edges. And so that's the basic idea of shining the laser on those pits, getting a reflection back. And so basically we have a laser. I'll just draw it here. Laser, I'm going to simplify this. There's a beam splitter that reflects that down through a lens onto the surface of the disc. That reflects back through the lens, through the beam splitter. So the beam splitter is just a couple of prisms cemented together. So we have this glass cube, and they're cemented in the middle, and so the light hits it and reflects that way. Of course, some of it goes through, but we don't worry about that. Reflects that way, goes through the lens, focuses, comes back through, and some of it reflects back, but we're not interested in that. We're interested in what goes through and goes to a optical sensor to be processed on the other end. And of course, there's electromechanics holding this lens to move it in and out, back and forth, to keep it in focus and keep it right on that little track. As the whole apparatus slowly moves across the disc, there's actuators in here that fine adjust the lens to keep it focused and tracking on these pits and lands as they go by on the disc. The LaserDisc was basically an analog system. So instead of directly recording the video on here, such as we think that as the voltage goes up, the picture gets brighter, the voltage goes down, the picture gets dimmer, etc., etc. As it goes across the screen, it gets brighter and dimmer. And we could actually make longer for brighter, shorter and dimmer, but actually this goes into a frequency modulator, and out comes out a frequency modulated sine wave that pulses the laser that creates the master disc that this is processed into these different lengths of on and off that are turned into these pits on the final product. So the end result was that the first laser discs basically had a composite video signal sent into the FM modulator, and that was used to pulse the laser to turn these on and off. And then it had a separate audio signal. I'll show that as a much longer wave. This video signal could be up to 4 megahertz, where this would be up to 20 kilohertz. And once that was put together, here's a picture from Wikipedia that shows the idea, but I don't want to get any deeper into this than I already have. The final result was that basically the video information was carried in the distance between the centers of the pits, and the audio information ended up being basically the length of the pits. That was the end result of combining those two, both audio and video signals, into the LaserDisc. Later on, this being a very high frequency of pits here, able to carry a 4 megahertz signal, there was lots of room for much more bandwidth in the audio, and they cobbled in there ways to do PCM, pulse code modulated digital signals, and so they were able to put in stereo and even more effects, even sometimes more than 2 channels. I'm being a little vague about how that works because I don't know exactly how they did it. It's hard to find specific information. But knowing that the system had to be able to handle a 4 megahertz signal and that the audio signal only had to be 20 kilohertz, there's lots of room for multiple audio channels. So they were able to squeeze in multiple audio channels using digital techniques. So that's the basic idea of how the LaserDisc was read. They had 2 basic formats of the LaserDisc. One was called continuous angular velocity. If you look at the disc, in fact, there's a picture of one close up. You could see a little wedge on each side. There's your label, and there's a little wedge on each side. And in here you could actually see, by looking at the right angles and the reflections, you could see the vertical blanking information on the disc. And so as it read the disc, it would read one field, the next field, the next field, the next field. So we have our interlaced video. We haven't talked about video yet. So in a nutshell, your TVs scanned odd lines first and then even lines. And so this would be the odd line information, even line information, odd line information, even line information. And then the vertical blanking was in there. And the advantage of that was you could stop the movement of the head and read the same frame over and over and over again and do stop motion on your TV, or slow motion, backwards motion. And each frame carried a number, and you could actually find out what frame number something was occurring at if that was useful to you. And that was useful in some ways that LaserDisc was used. So that was the continuous angular velocity, but that could only handle a half an hour of video per side on the disc. And that was, again, continuous angular velocity, or CAV. They also developed continuous linear velocity. And what that did is, if you can think about it, well, if they can squeeze one frame into this area here, out around the edge, well, that's more real estate. I should be able to squeeze in more frames, and which is exactly what they did. As the head worked its way out, the disc would slow down slower and slower and slower. And so we have the same amount going through with time, but since we had more distance, we were able to squeeze a lot more, several more frames around the edge than in the middle, and you could squeeze about an hour of video on a CLV disc. Later on, they developed something called CAA, Continuous Angular Acceleration, which was basically the same thing as CLV, but it wasn't a smooth transition from inner to outer part. It was handled in steps, and that was able to make some improvements in how the video was handled and fewer artifacts in the final product. Early LaserDisc players, as I said, used helium neon lasers, but shortly afterwards they were changed to diode lasers. And if I understand correctly, typically they would use a red laser for LaserDisc, and of course by that time they were also coming out with LaserDisc players that would also play compact discs, because they're essentially the same technology, but they would use an infrared laser for the compact disc and a red laser for the LaserDisc, although I don't see why they couldn't have used the red laser for both, but that's the way I understand it. There may have been technical reasons to make it easier to use infrared for CD and red for video. Another thing they did with LaserDiscs, especially with the CAV discs, is you could make computer-controlled LaserDisc players, and you could have it show different parts of a video at will. So, for example, one of the common uses of a LaserDisc was to put a single image on each frame and show still images. And you could basically do computer-controlled slideshows using the LaserDisc. Another thing was to use presentations where you could use different video snippets, and one of the most famous uses of that was a video game called Dragon's Lair. In the day before good high-quality computer animation could be done, they did hand animation and made the videos and put them on a LaserDisc. And so there's a LaserDisc in the Dragon's Lair player, and as you played the game, it would show you different videos on the LaserDisc. There were problems with it, like you came to a puzzle, and if you solved the puzzle, it had to blank the screen, move to the correct video, show the correct video of you moving on to the next level, or if you died, it had to stop and go find the video of Dirk, the character in the video, dying. And so it was a little clunky, but it was kind of fun, and the animation, of course, was much better than any video games of the time. If you're interested, you can do a search on YouTube for Dragon's Lair, and you can see the entire LaserDisc with every part of the game, all the advances, all the ways that Dirk died, in one continuous video. LaserDisc's biggest drawback is that you could not record on it. At the time that LaserDisc was coming out, we had videotape. VHS and Beta were popular. VHS was starting to win the market. And even through the demise of LaserDisc, we still had those video formats to use. It wasn't until DVD came along that finally LaserDisc died. But LaserDisc was better quality than videotape, but you could not record on it. They did experiment with recordable LaserDiscs. I understand that Lucasfilm used LaserDiscs for viewing their dailies when they're out filming, but nothing caught on in the consumer market. And what got to the market was very, very expensive, and people wanted to be able to record their television in those days. It wasn't like today where people stream at will. Your TV show came on at a certain time, and if you couldn't be home to watch it, you wanted to use your cassette recorder to record that video. Or what if the video was in the middle of the night? You could set your recorder to record it and watch it at leisure. They called that time shifting, something that's fallen by the wayside. They did this digitally for a while, but you can still get DVRs, digital video recorders, but they're not nearly as common as they were, because most people are streaming their video these days, or putting their video on hard drives. And so not that many people are recording video these days on an optical media. So in the early 1980s, LaserDisc was about to die, at least in the American market. Apparently it was doing very well in the Japanese market, but in the American market it was dying a slow death. But what saved the LaserDisc, of course, was taking the same technology, shrinking it down, and using an infrared laser and recording audio on there. So So I'm not going to talk about the audio compact disc now. That's going to be in the next video. But that is what saved LaserDisc, is taking the same technology and shrinking it down and putting audio on it. And that became very popular. Of course, one reason that worked is because they developed inexpensive, small infrared LEDs that could read the compact disc. And so it was very affordable. And it was just a slight difference in technology to use LaserDiscs. And so once the compact disc came out, they were able to make LaserDisc players that could play LaserDisc or compact disc. And also, since they were developing the technology for compact disc, which was virtually identical, it brought down the cost of developing LaserDisc. So the compact disc saved the LaserDisc. So the difference is that instead of recording analog video, we record digital audio. Basically, your lands and pits are your ones and zeros. So the audio was sampled 44,100 times per second and then converted into 16-bit pulse code modulation audio and stored on the disc. So that's about all I have to say about the beginning of optical recording and the granddaddy of them all, LaserDisc. And I will talk about compact disc and its successors in subsequent videos. So I hope you found this useful and informative. And if you did, please give me a thumbs up down below. It really helps the channel, helps other people find these videos. And if you want to study electronics technology, you can go to Vocademy.net and take my free course. And as always, a big thank you to my patrons at Patreon and my one-time donors. I could not make these videos without your support. So to help me put these videos online, go to patreon.com/Vocademy and pledge your support. Or go to paypal.me/voced, V-O-C-E-D, vocational education, and pledge your one-time donations. Again, a big thank you to my patrons and one-time donors, and thanks to everyone for watching.